So Lab 2 is not entirely simulation based. Part of it is implementation, but the implementation is straightforward. You'd have to upload your designs into a Max5 Altera. This is what the board looks like. You have 40 GPIO pins. I'll show you later how you can use these GPIO pins, but you need to be careful when using them. You have to read the data sheet. I'll show you later how to use them. But what you basically do is just design, simulate, and then load, and that's it. So for now, I needed to show you how you can get a clock from. I needed to show you how you can get a clock from the Max5, because on our lab 1 we were using a 555 timer, but now there's a convenient way to make a clock. 10 megahertz, yeah. And here, since you're going to be using the Max5 Altera, this part is really important. If you go to your lab sheet, you'll realize Prof gave you this number, this model here, this module here. So make sure that this is what you select when you're creating the project. This is the device that you have to select when you're designing the project. Just remove the end there. Yeah, make sure you select this device because that's what you'll be using on your labs. And then simulation, make sure you choose model sim. In the end, it depends on how you install your thing, how you install your cutters. But if you're using 20.1, then you should be using model sim. And again, Lab 2 supports VHDL, so make sure you choose VHDL here, and then you go next, and then finish. So I need to show you how you can get a clock. If you go back to this thing here, the board has 3 clocks, 3 crystals. This is your 10 megahertz. It's a 10 megahertz right there. And then they didn't label the others. Yeah. But you have a 24 megahertz there and a 6 megahertz there. But we won't be using these two. We won't be using these two. We are only going to be using the 10 megahertz. So here, if you want to load the clock, make sure this thing is open. IP catalog, and here search for LPM counter. LPM counter. Yeah. Click that. Double click that, and then here you name your clock CPU or anything you want. Let me see. Yeah, it's a CPU. Make sure it's VHDL, but it doesn't really matter here. But just keep your things VHDL. Where you have to choose in hardware language, just choose VHDL. And here, choose 24 bits. And then your modulo here should be 10. So 10 megahertz. That's 10 million. 1, 2, 3. 1, 2, 3. So this is 10 million. This is 10 million. So what you're doing here, you are dividing the 10 megahertz by 10 million to get 1 second. To get 1 second. Yeah, and that can be stored with 24 bits. 24 bits. So yeah, just be careful here. You have to use 24, and then you divide by 10 million to get that. The highest bit here. Highest bit will represent 1 second. I'll show you later how that works. So go next. Make sure you select all of these here, especially this one, and then you click finish. And you click finish. So since you named the thing, it's going to show up under projects. When you go to your components, it is going to show under CPU, under project file there. So see, this line here represents 24 bits, 23 to 0. So just drag it out like this, and then rename it. You can click it and press the space bar and name it as it is on the label. It's 23, 2 dots and 0. So that's 23 to 0, and this one is your input, and this one is your input. That is your CPU. Let's take an output just to demonstrate, just to get an LED to blink. This they call it a bus because it's 23. This is 24 lines. See, this one is just one line, and this here is 23 lines. So you should take note of that. This is 23 lines. So to access one of the lines, all you do is just say Q23. That selects the highest line, which is what we are going to use to get the 1 second. And then, as usual, you have to name your outputs. Especially for this lab, you have to name your outputs. That is not an option. So you have to always make sure that you label your outputs. So after that, just build, save that, and then build. So after building that, you go to this thing here, pin planner. There's pin planner here. So what you want to do, click here, this clock. It says here H5. So you're going to take that H5 and type it under location. Just say H5 and press enter. It's going to write, H5 goes to clock. That's H5 goes to your CPU. So when you do this, you're connecting this pin from the Altera MX5 to the CPU pin that you set as an input. Remember here, you set this line as an input. So what you're doing here, you're trying to capture the clock to go to that pin. The clock will go from that pin to the LPM counter. This LPM counter will divide the 10 megahertz and then output that as in 1 second. So that's going to be 1 second. And then your LED. So your MX5 has two user-defined LEDs. So as usual, you're going to go to your data sheet. Just scroll down. This is okay. I'll come back to this. LED. These are your switches and these are your LEDs. So these are your two user-defined LEDs. So if you want to select LED on the board, it's written D6 and D7. So if you want to select them, you're going to have to write P4 and R1 depending on whichever one you choose. So go back there. So here, if you want to choose either one, that's P4 and R1, I think. P4. That's P4. So that's how you choose the first LED. If you had if you wanted to choose the second LED, you were going to just write that R1. So this just by doing this, you're effectively connecting this. So just by doing this, you're effectively connecting this output to the LED on the board. So you'll see them. There's two LEDs here. There's two LEDs here. Two LEDs. That's a power LED, and that's a programmer LED, and these are your two LEDs. So if you want to select these two LEDs, you use P4 and R1. Yeah, you use P4 and R1. Same thing as switches, but we'll come back to that later. So for now, I think for this basic example, we're all set. Just after setting up your pins, close that. You don't even need to save it, just close it and then build again. And then just build again. Right, so after doing that, you have to go to your programmer. There's a programmer there. It says programmer. So click programmer. Yeah, I'll try to send some drives so that if you want to demonstrate with your laptop, then you'd be set with the drives. But it's an easy thing. So this is how you program. You have to select these. And make sure your hardware here it selects the USB. So after that, it is straightforward. So as you this is what the board looks like. This is what the board looks like. So as you can see, let me see. As you can see, these LEDs are blinking at the same time, and your power LED is on and everything. So here, it's obviously not running what we programmed here, because here you only have one LED. So if I want to program this, all I do is say start. And now an LED is blinking. But yeah, so this other one will remain high, but this is effectively how you program the Altera. So let's just turn this one off. Let's see if we can turn this one off, this other LED off. Let's see if we can turn this other LED 2. LED 2. Just put that to ground and say GND. GND. Or we don't turn it off just like that. Or we can demonstrate something else here. Take an input. let's just say switch 1. Let's switch 1. I don't know if I'm gonna need this. So what I'm trying to do here is I'm trying to connect the switch to this LED, the one that is always on, because by default they are on. By default they're on. So I'm just trying to, yeah, so this is a switch. It's going to control this LED. So effectively, since by default they're on, I want to send a 0 to it. So when I press the button, then it's gonna go high. Yeah, so I don't need this. And then build that. Yeah. So in the meantime, let's look at our data set. S1 is R3, S1 is R3, and S2 is M9. S1 is R3, and S2 is M9. So it finished. You go back to your pin planner, and you set your LED2. LED2 was R1. You said it's R1. Let's confirm that. LED2. Yeah, that's R1, second LED. And then we're using R3 and M9. So which one is R3? S1 is R3. Alright, it's fine. R3, close that. You close that, go back to your, and then go to your programmer and start programming. And let's see. So let's see, if you press S1, okay. Oh, I see what happened. Let's see what happened here. Because they are high, they both high, so yeah. So yeah, program that. Yeah. So yeah, if you press the button, the LED goes high. If you press the button, the LED goes high. If you press it, it goes high. Press it, it goes high. And the other one is just blinking. So that's basically how you use it. If you want to, all you do is just do your simulations, and you check on the data sheet what pin is associated with one of your inputs or your outputs, and then you assign those pins using this pin planner. All you do is just type the corresponding pin number as in your data sheet. You just type this thing, these numbers. See, it says here pin number. See, it says here pin number. Sometimes it's confusing. Yeah, use these pin numbers. Just type this number and then press enter, and then effectively assign your pin.